So let's us solve the problem bumps from Bergen Open 2021. So in this problem, the input is a graph and the location of some bumps. And the question is, can we move the bumps to this configuration? How many days are needed to do this? And there are some constraints. Well, you can do at most one bump per edge per day. And also you can do at most one edge per bump per day. Let's look at the picture of how this sample case is solved. So we have the starting configuration on day 0. And then on the first day, what we do is we move the blue bump along this edge and the red bump along this edge. And then on the next day, there are lots of movement in the graph, so bumps are moving all over the place. So the answer to this sample input is 3. Okay, so let us visualize this sample case in a slightly different manner. Okay, so what we have here is sort of a matrix where you have one location for each day and for each vertex of the graph. So in this picture, let's draw how, for instance, the blue bump is moving through the different vertices, right? So on day 0, it starts up here, and then on day 1, it moves over here. So we get this movement of the blue bump. And then it moves to vertex number 2, and then finally it moves to vertex number 3 on the last day. So let's do the same, but for the red bump, and for the green bump, and for the black bump, and finally for the green-red bump. So now that we have this picture of the flow, it shouldn't be too hard to see how you can turn this into a flow problem where you're basically asking for a flow for the bumps to their locations. You basically add a vertex here. You give the capacity of how many bumps you want for each vertex. You know, inside of this graph now I've only drawn the edges where the flow is actually flowing, but you know, you have to add all of the edges where the bump could move, right? So so you cannot have a flow like this, for instance. So basically, you know, you add the edges in between here. That is possible given the original graph. And then you run a max flow from the source to the sink. And if the max flow is equal to the number of bumps, well, then you were able to move them. So to see how to recover how the bumps move after you find the flow is quite easy, right? You know, you pick one of the flows, right? And then if it moved like this, then it means that on this day it moved through this edge. And the other restriction, at most one bump per edge per day, is also fine in this picture, right? Because you know, you cannot have two flows along the same path, you know, unless the capacity here is 2. I mean, you set the capacity here to be 1, you know, unless there are 2 of them, then the capacity is 2. But in any case, that will work out nicely. So the last thing that remains is to find the correct number of days to build a graph for. And the correct number of days, you know, is the smallest number of days such that you are able to find a max flow, which is equal to the number of bumps. So basically, you guess, you put the binary search around this thing, and there you go.